Hello and welcome to my quick quiz on probability trees. There are 6 questions. You just need a pen and a piece of paper to write down your answers. So let's get started. Question 1. A box contains pink and blue highlighters. There are 9 pink and 5 blue highlighters. A highlighter is picked at random, then replaced. A second highlighter is then picked. Find the probability of picking 2 pink highlighters, picking a pink highlighter then a blue highlighter, picking a blue highlighter then a pink highlighter, picking 2 blue highlighters, picking 2 highlighters of the same colour, picking 2 highlighters of different colours, and picking at least 1 pink highlighter. Question 2. There are 20 books on a bookshelf. 9 of the books are English books and 11 are maths books. I take one of the books from the shelf, have a quick look at it and then replace it. Then I take another book at random. Draw a probability tree to represent this. Then work out what the probability that both books I take are English books, the probability that both books I take are maths books, and the probability that one book is English and the other is maths. Question 3. A box contains red and yellow pens. There are 5 red and 2 yellow pens. 2 pens are picked at random without replacement. Find the probability of A, picking 2 red pens, B, picking a red pen and then a yellow pen, C, picking a yellow pen and then a red pen, D, picking 2 yellow pens, E, picking 2 pens of the same colour, F, picking 2 pens of different colours, or G, picking at least 1 red pen. Question 4. Here is a pack of 52 playing cards. One card is taken at random and not replaced. A second card is then picked at random. Draw and complete a probability tree diagram as below to show picking an ace from the pack or not picking an ace from the pack. Then work out the probabilities that the second card is an ace if the first card is an ace, and work out the probability that the second card is an ace if the first card is not an ace. Question 5. 2 buses use the same bus stop. The probability of the 292 bus arriving early is 0.7 and the probability of the 107 bus arriving early is 0.4. Draw a probability tree diagram to represent this. Find the probability of both buses arriving early and find the probability of at least one bus arriving early. Question 6. There are 4 red cubes, 3 blue cubes and 1 white cube in a crate. 1 cube is taken at random and not replaced, and then a second cube is taken at random. Draw and complete a probability tree diagram. Find the probability that both cubes taken will be blue, and then find the probability that both cubes taken will be the same colour. Also, find the probability that exactly 1 cube will be red. That's the end of the questions. Let's move on to the answers. Question 1. We have 9 pink and 5 blue highlighters, so a total of 14 highlighters. On the first pick, the probability of picking a pink highlighter is 9 out of 14, and of picking a blue is 5 out of 14. As we replace the highlighter we first picked, we still have 9 pink and 5 blue highlighters to pick from. The combinations of highlighters being picked are pink then pink, pink blue, blue pink, or blue blue. These are the calculations that need to be made following along the branches. The probability of picking 2 pink highlighters is 81 out of 196. The probability of picking a pink then a blue highlighter is 45 out of 196. The probability of picking a blue highlighter then a pink one is 45 out of 196. And the probability of picking 2 blue highlighters is 25 out of 196. When calculating picking 2 highlighters of the same colour, we add together probabilities for pink pink and blue blue. We then cancel, getting 53 over 98. When calculating picking two highlighters of different colours, we add together pink blue and blue pink, then we cancel, getting 45 out of 98. To calculate the probability of at least one pen being blue, we add together pink blue, blue pink and blue blue, getting 115 out of 196. Question 2. We have 9 English and 11 maths books, so 20 books in total. The probability of picking an English book the first time is 9 out of 20, and if we picked a maths book the first time, the probability will be 11 out of 20. As the book picked first was put back on the bookshelf, we still have a total of 20 books to pick from. We still have 9 English books and 11 maths books, independent of whether a maths or English book was picked the first time. The combinations of books being picked are English then English, English then maths, maths then English, or maths then maths. These are the calculations that need to be made following along the branches. We can instantly see that the probability of both books being English is 81 out of 400. The probability of both books being maths is 121 out of 400. And in order to calculate one of each book being picked, we need to add the probabilities of the combinations English maths and maths English. This gets 99 out of 200 after cancelling down. Question 3. We have 5 red and 2 yellow pens, so a total of 7 pens. On the first pick, the probability of a red pen being picked is 5 over 7, and the probability of a yellow pen being picked is 2 over 7. It is important to note that in the question it says that the pens are picked without replacement. This means that in the box there are now only 6 pens to pick from. If we picked a red pen the first time, then we now only have 4 red to pick from. If we picked a red pen the first time, the number of yellow pens hasn't changed, so we still have 2 yellow pens in the box to choose from. If we picked a yellow pen the first time, we still have 5 red pens in the box to choose from. However, if we picked a yellow pen the first time, we now have just 1 less yellow pen in the box, so we only have 1 yellow pen to pick from. The combinations of pens being picked are red red, red yellow, yellow red, or yellow yellow. These are the calculations that need to be made following along the branches. The probability of picking 2 red pens is 20 out of 42, which cancels down to 10 out of 21. The probability of picking a red pen then a yellow pen is 10 out of 42, which cancels down to 5 out of 21. The probability of picking a yellow then a red pen is 10 out of 42, which cancels down to 5 over 21. And the probability of picking 2 yellow pens is 2 out of 42, which cancels down to 1 over 21. Part E of the question asks for the probability of picking 2 pens of the same colour. The combinations needed are red red and yellow yellow. We just add together 10 out of 21 and 1 out of 21, getting 11 over 21. Next, we are asked for the probability of picking pens of different colours. The combinations needed are red then yellow and yellow then red. We add together 5 over 21 and 5 over 21, getting 10 out of 21. The last part of the question asks for the probability of picking at least 1 red pen, so the combinations we need to add together are red red, red yellow and yellow red. This gives us the probability of 20 over 21. Question 4. 4 out of the total pack of 52 cards are aces, which means that 48 are not aces. As we picked a card the first time and did not replace it, we now have a total of 51 cards to pick from. If we picked an ace the first time, we now have 3 aces left in the pack and 48 cards that are not aces. If we did not pick an ace the first time, we still have 4 aces left in the pack, but we're 1 down from the other cards, leaving 47 that are not aces. The combinations of cards being picked are 2 aces, an ace then a card that is not an ace, a card that is not an ace and then an ace, or 2 cards that are not aces. The first question is to find the probability that the second card is an ace if the first card is also an ace. We multiply along the ace-ace branches and get 1 out of 221 after cancelling. The second part of the question is to find the probability that the second card is an ace and the first card is not an ace. So we follow the not ace-ace branches, we multiply, and we get 16 out of 221. Question 5. Starting with the 292 bus, we know that the probability of it arriving early is 0.7. That means the probability of it not arriving early must be 0.3. It makes no difference to the arrival of the 107 bus whether the 292 is or is not early, so the probability of the 107 being early was given in the question as 0.4, making the probability of the 107 not being early as 0.6. The combinations for the two buses are both early, 292 early but the 107 not early, the 292 not early but the 107 is early, or neither is early. These are the calculations that need to be made following along the branches of the tree. In the question, it asks for the probability of both buses arriving early. We can see that it is 0.28 for early. In order to calculate at least one of the buses arriving early, we need to add early then early, not early, and not early and early, getting 0.82. Question 6. We have 4 red cubes, 3 blue cubes and 1 white cube, so we have a total of 8 cubes to initially pick from. On our first pick we have 4 out of 8 for red, 3 out of 8 for blue and 1 out of 8 for white. As we've taken out a cube and not replaced it, we have a total of 7 cubes now to pick from. We picked a red the first time, so now we have 3 to pick from. When we pick a red the first time, the numbers of blue and white cubes didn't change, so there are still 3 and 1 to pick from. When we pick a blue the first time, we have 1 less blue to pick from the second time, so now we have 2. The number of red and white cubes hasn't changed, so we still have 4 and 1. When we pick a white the first time, we now have no white cubes to pick from, but we do still have 4 reds and 3 blues. The combinations of cubes being picked are red then red, red then blue, red then white, blue then red, blue then blue, blue then white, white then red, white then blue, or white then white. These are the calculations that need to be made following the branches. The first question asks for the probability that both cubes picked are blue. We just look up the blue where we have worked it out as 6 over 56. But we now just need to cancel the fraction, getting the answer as 3 over 28. The next part of the question asks for the probability that both cubes are the same colour. The combinations we need are red red, blue blue and white white. These have already been worked out, but we need to add them together, getting 9 over 28. The last part of the question asks us to find the probability that exactly one cube will be red, so we use the combinations red blue, red white, blue red and white red. We don't use red red as that is not asked for, just one red is required. We add the probabilities of these combinations and get the answer of 4 over 7. Well, that's the end of my quick quiz on probability trees. I hope you enjoyed it. I really hope you'll come back to Melissa Maths again soon, and don't forget to hit that subscribe button. Bye!